Today we're going to discuss the mathematics of finance, in particular, annuities. The big item that I want you taking away from this lecture is that annuities involve regular payments. There are two types of annuities that we're going to discuss today: future value and secondly, present value. I'll give you the formulas and then we'll discuss each of these. For future value, we have the future value equals the regular payment times the quantity of 1 plus r over n, all to the nt power minus 1 in the numerator divided by r over n. For present value, it's very similar. The present value equals r times, in the numerator 1 minus 1 plus r over n, this time to the negative nt divided by the r over n. Let's define some of our unknowns here. The uppercase R is the regular payments. The lowercase r is the interest rate. There are times where the interest rate is going to fluctuate. For us, we're going to simplify and say that we have a constant, consistent interest rate throughout the problem. N is going to represent the number of payments per year. And finally, T is going to represent the number of years. So what's the difference between future value and present value? Here are some examples. For future value, this could be investment into your future. An investment into an IRA, into a 401k, into a Roth IRA. But we're going to be contributing to this account in regular payments at a continuous constant interest rate for a certain number of times per year for a certain number of years. And we're concerned with what the future value of this account is worth. What will this account be worth in 30 years, in 40 years, when I'm able to retire? Present value will be things like a mortgage payment, a car loan, student loans. For all of these, I currently have a value, a present value. Now it's a negative for me. I have a value that I owe the bank. I have a value that I owe the dealership. I have a value that I owe the government back for my student loans. There's a present value to my account that I would like to pay down to zero. Whereas future value, I'm going to start at a zero value and hopefully pay that up to be a larger future value. Let's look at a couple examples. First, Dyson is currently 18 years old. His father gives him incredible advice about financial planning. As a result, Dyson starts investing $150 quarterly into a 401k retirement account. If the account were to earn 7.6 APR, that's our interest rate, how much money would Dyson have in his account at the age of 67? How much money did Dyson contribute in total? One thing that we are simplifying here is that the interest rate of 7.6 is going to be constant and consistent. We can't guarantee that, but for this problem, we will. We're also going to guarantee that Dyson is contributing $150 every single quarter until he's 67. So the big first question we need to answer is this a future value or a present value? Because we're worried about this value at 67 in the future, we're going to talk about a future value here. The future value equation, future value equals the regular payments, 1 plus r over n, to the nt minus 1 over r divided by n. What are our knowns? What are our unknowns? What are we looking for? Here, we're going to be looking for what the future account will be worth. We're looking for the future value. We're going to plug in for the regular payments of $150. We're going to plug in for a rate of 0.076. We need to list that as a decimal. Quarterly would be 4 times a year. 4 times a year for 67 minus 18 would be 49 years. We're going to subtract 1 in that numerator. In the denominator, I have the 0.067 divided by the 4. This is going to require some computation in our calculator. I would first determine what the quantity inside the parentheses is going to be, and that's going to be 1.019 to the 196th power minus 1 divided by 1.019. I can then take it to the 196th power, subtract 1, divide appropriately, and multiply by 150. I should get a future value of 307,952 and 97 cents. This is going to be the amount that Dyson has in his account at the age of 67. It's important to compare this to how much money did he actually contribute. Hopefully this number that he actually contributed is a lower number. So to determine that, we would say he's doing 150, which is our regular payment, 4 times a year, which is our number of payments per year, for 49 years, which is our T. If we do 150 times 4 times 49, we'll find that he has contributed $29,400. A comparison of these two numbers will lead to a good conversation about, was this a good investment? The second problem we're going to do involves Holton. Holton's currently looking at colleges. Holton calculates that after scholarships and some help from his parents and grandparents, he'll have a total of $125,000 in student tuition loans upon graduation. If he can secure a loan at a 4.29% APR that needs to be paid off monthly over 10 years, what would Holton's payment be? How much money did Holton actually pay for tuition? Because the account has a current value, a present value of $125,000 that he's looking to pay down, we're going to use a present value annuity. Present value equals R times 1 minus 1 plus R over N to the negative NT, and we have the R divided by N in the denominator. We're going to plug in here. This time we know the present value. The present value is $125,000, and we're seeking to find what those payments are. The rate here is 0.0429 divided by 12, because we're paying this off monthly, to the negative 12 times 10 years, divided by 0.0429 divided by 12. Again, this is going to require some computation in our calculator. I would take this over the course of a couple steps. I would first compute the value inside the parentheses to be 1.003575, and this is going to be to the negative 120th power. In the denominator, we're going to have 0.003575. Be careful not to round mid-problem, because that's going to lead to larger rounding errors by the end of the problem. I would now take to the negative 120th power 1 minus that quantity, divided, and then divide that over into the 125,000. That might be a couple steps there. I get regular payments here of $1,282.86. Again, this is going to be important to compare this to how much did he actually pay for tuition. So if we did that calculation, we would say he paid a regular payment of $1,282.86. He did that 12 times a year for 10 years. This number comes out to be $153,943.66. Again, if we compare the amount that he wound up paying compared to the amount that he initially would have paid for that student tuition, we can have a good conversation about the value of this loan for Holton. I'm going to leave you with two problems. First, Quinn purchases his first car. He's going to finance the whole amount of the car because the dealership's offering a great rate of 0.9%. If he's paying this off monthly over 5 years, what would be the monthly payments, and how much did Quinn actually pay for the car over those 5 years? Second, this is our challenge here. Sutton begins contributing to her IRA. She'd like to retire in 30 years. She'd like to have $1.5 million in that account. What interest rate would Sutton need to earn Is that a realistic interest rate? Is this scenario realistic?